Good day, my viewers. You are welcome to my channel. On today's topic, we'll be looking at isotopy. Mass spectrometric studies shows that atoms of most elements exist in more than one form. I will call them what? Isotopes. So what are isotopes? Isotopes are atoms of the same element that have the same mass, the same atomic number, but different mass numbers. So, and the phenomenon is what we call what? Isotopy. Isotopy is the phenomenon whereby atom of an element exhibits different mass numbers, but they have the same what? Atomic number or number of proton. Practically every element exhibits isotopy. Okay, look at chlorine. For instance, chlorine has two what? Has two isotopes. You have chlorine with mass number 35. And that of what? Chlorine mass number what? 37. Hydrogen has three isotopes. So you have what? Mass number 1, mass number 2, and mass number what? 3. But you can see the atomic number is what? The same. Chlorine is 17. So you can see. So the difference in this mass number is because of what? Difference in the number of what? Neutron present in the atom of this what? Element. Okay, look at this. This chlorine is mass number 35. The number of neutrons. Remember, if you want to find the number of neutron, mass number minus what? Number of proton. So mass number minus number of what? Proton. Minus proton number. So what's the mass number for this is what? 35. What's the number of proton? That's 17. Which is what? 35 minus 17 will give us what? We're having 18. If you do the same for this one, you'll be having 37 minus 17, which is what? 20. You can see. Because of difference in what? Number of neutron. So I want to state that isotopes of the same element. These two elements are seen here. Their physical properties differs because this neutron contributes what? To the mass of the atom and not to what? The chemical properties of that what? Of that element. So you can see this one with mass number 20 and mass number 18. Which one do you think will be what? Will be denser than the other, will be heavier than the other? Of course, this one mass number. The number of neutrons being 20 and the mass number being 37 will be what? Slightly what? Denser, heavier than this what? This one with mass number 35. So that shows atoms of the same element, they have what? Isotopes, they have what? They exhibit different physical properties, but the chemical properties are what? The same. In a multiple choice question, you can be given something like this. And you are asked, which phenomenon does this element exhibit? You can see that the same atom of the same element XXX. And if you look at the number that is done, they are the same. PPP. That's what that represents what? Atomic number. But this one differs. NMV. The mass number differs. So which means this element, what does it exhibit? Isotopy. Isotopy. Please know when to use isotopy and isotopes. So the phenomenon is what? Isotopy. Okay, let's calculate the relative atomic mass of chlorine atom, which contains 75% of the chlorine, one of the isotopes having mass number 35, and the other one 25% with mass number or isotopic mass 37. Okay, let's look at it. Relative atomic mass of chlorine. So remember, this relative atomic mass of chlorine itself is what? Contributed is by each of the what? Isotopic mass of this one with what? mass number 35, another one mass number 37. Okay, let's look at this. This is 75%. 75. If you want to remove percentage, you divide by what? 100 times the isotopic mass, which is what? 35, plus 25. Remove the percentage by dividing by 100 times the isotopic mass of chlorine, which is what? 37. 75 over 100 will give us what? 0.75 times 35, which is what? 26.25, plus 25 over 100 will give us 0.25 times 37, which is what? 9.25. 9.25. So if you sum these two together, you have what? 35.5. 35.5. No units. Remember, relative atomic mass does not have what? Not carry any unit. Okay, look at, so this is 35.5. I want to state that relative atomic mass of element, it's not a whole number ratio. You will not see a whole number ratio like, okay, this is 36, 35. Even the one of hydrogen is what? Hydrogen is what? 1.008. Approximately 1. So relative atomic mass of chlorine is 35.5 because of what? Presence of what? Isotopes. Because it's the average is the weighted average of what? Isotopic mass of each of these elements that contributed. So if you ask, give reason why isotope of chlorine is what? 35.5, or the isotope of hydrogen is what? 1.008. You just say because of the what? Presence of what? Isotopes, or isotopic what? Mixture. That's the answer. What? Question number 2. If a sample of an element R exists in a ratio 1:2:3, calculate the relative atomic mass of each isotopes of R, given that the relative atomic mass is 1.1. Okay, so solution. We are going to add the sum of, we'll add up what? This ratio. Sum of ratio. Sum of ratio is what? 1 plus 2 plus 3, which is equals to what? 6. We're going to find, the question says, calculate the relative atomic mass of each isotopes of R. So we have to find the isotope of R with what? Ratio 1. Another what? Atomic mass of what? Isotope of R that has this ratio 2, and that of 3. The one with ratio 3. Okay, relative atomic mass of R. Relative atomic mass of R. R of ratio 1. So it's equals to what? So the one with ratio 1 is this 1. 1 over what? The total number of ratio, which is what? 6, times the relative atomic mass of R. The relative atomic mass of R. This relative atomic mass of this element R. But we want to find, what are we looking for now? Calculate the relative atomic mass of each isotope of R. We are looking for each isotope of R that contributes to one that has this ratio 1. After that, we find the one with ratio 2. The one that has ratio what? 3. So how do you do it? The ratio divided by sum of ratio times the relative atomic mass of the what? of the element. So 1/6 times 1.1. So 1/6.1.5, 0.18, 0.18. So do the same, the one with ratio, relative atomic mass for ratio 2. So this one is 2/6 times 1.1. So what do we have? Having 0.36, 0.37. So we do the same for the other one, the one with ratio 3. So relative atomic mass for ratio, the one with ratio 3 will be what? 3 divided by what? 6 times 1.1, 0.55, 0.55. Let's look at question number 3. Chlorine has 2 naturally occurring isotopes with mass number 35 and mass number 37. If the relative atomic mass of chlorine is 35.5, determine the percentage abundance of each isotopes in naturally occurring chlorine. Here, we are not giving the relative abundance, as in the first example. We are not giving the ratio of abundance, as in the other one. So, let me clean this board so that I have a bigger space to work with. So let the percentage abundance of chlorine having the mass number. When it comes to a question like this, I like to use the isotope with what? With a bigger mass number to start with. So let the percent abundance of chlorine 37, let it be what? X%. Let the percentage abundance of chlorine with mass number 35. If I know that this one is X%, how do I get the other one? 100 minus what? X. So let it be 100 minus X%. Okay. So start. X, if you want to remove this percent, X over 100 times, how would you do the first one? When you know the percentage abundance, you divide it by 100 times the mass number. So the same we're going to do to get what is our S, what's going to give us. Times 37 plus 100 minus X times, so because it's times the mass number, we use enclosed in bracket, times the mass number 35 divided by 100 to remove percentage equals to what? What's the relative atomic mass of chlorine? It's given in the equation as 35.5. X times 37 gives us 37x divided by 100. So we're having 0.37x plus, you have 30, this 35 will times 100. 35 times 100 is what? 3500 minus 35 times x is what? 35x divided by what? 100 equals to what? 35.5. 0.37x plus This 100 divide this one, you have 35 minus 100 divide this, you'll be having what? 0.35. 0.35x, which is equals to what? 35.5. So next thing I'm going to do is do what? To collect like terms. I'll collect like terms. So 0.37x. This one coming here, that's minus 0.35 what? X is equals to. This one's already here. 35.5. This is plus 35. Crossing the equality sign becomes what? Minus 35. So 0.37x minus 0.35x, you give me what? 0.2x. 35.5 minus 35 will give me what? 0.5. So 0.37x minus 0.35x, I'll be having what? 0.02, not 0.2. 0.02x. So 35.5 minus 35 give you 0.5. So what's s? Okay. So if you want to find x, you divide both sides by 0.02. So s is what? 0.5 over 0.02, which will give us what? 25%. So remember the statement to say let the percentage abundance of chlorine with isotope 35, let it be what? X percent. So I've gotten our S to be what? 25%. How do we get this percentage abundance of chlorine with isotope 35? It will now be what? 100 minus 25. So the percentage abundance of chlorine 37 mass number is what? 25%. So that of what? Percentage abundance of chlorine with mass number 35 will be what? Is 100 minus 25%. 100 minus what? 25%, which is what? 75%. Remember, if you are asked, instead of percentage abundance, you are asked to find their ratio of occurrence ratio. You say the same thing. When you get to this point, the next thing you're going to do is do what? Divide this into the lowest term. 25 divide this self 1. 75 divide 25 will give you your 3. So this will be the ratio of what? Of abundance. Okay, solution. So remember, in calculating what? Relative atomic mass of isotopes, we don't make use of what? The atomic number. Even if it's given there, we don't make use of it. Okay, let's start. This mass number, atomic mass with mass number 20, atomic mass 20 occurs 25%. So 25, we remove the percentage, divided by 100 times the mass number, which is what? 20, plus the one with mass atomic mass x, which we are looking for, occurs 75%. So 75, we remove the percentage by divided by 100 times the mass number is what? X. We don't know it, we're looking for it. So what's the relative atomic mass? 21.5. So 25 over 100 will give us what? That's 0.25. 0.25 times 20 is 5. Plus 100 divided 75 will give us what? 0.75 times x will give us what? 0.75x equals to what? 21.5. So I'm going to collect what? Like terms. 0.75 x is equals to what? 21.5. This plus 5 crossing the quality sign becomes what? Minus 5. So 0.75 x is equals to what? 21.5 minus 5 will give me what? 16.5. How do I find x? When I divide both sides by 0.75, I'll be finding my what? X. So x is equals to what? X is equals to 16.5 divided by what? 0.75. 16.5 divided 0.75 is 22. So x is equals to what? 22. So I find my x to be what? 22. So which means this mass number is what? It's 22. We've come to the end of today's video. If you are seeing this video for the first time, kindly subscribe to my channel, like and share so that it can get to more people. Thanks for watching. I have a great day. Bye.